Assalamu alaikum, student. Today, we embark on a fundamental journey into the heart of manufacturing, the foundry. Tell me, what comes to your mind first when you hear foundry?
Walaikum assalam, Ustad. I think of melting metal and making shapes, like casting. But it feels very complex, with heat and dangerous processes. Precisely. At its core, a foundry is a factory that produces metal castings. We melt metal, pour it into a prepared mold cavity, let it solidify, and then extract the desired component. It's a foundational industry, transforming raw materials into complex parts.
So, what are the main stages involved in this transformation, Ustad?
Broadly, we can break it down into 6 key stages: melting, molding, pouring, solidification, shakeout, and finally, finishing. Let's start with melting, as this is where the magic begins, but also where precision is paramount. What kind of temperatures are we talking about for melting? And what equipment do you use? The temperatures vary significantly depending on the metal. For cast iron, we're typically looking at around 1150 to 1250 degrees Celsius. For steel, it's much higher, say 1400 to 1550 degrees Celsius. Aluminium, on the other hand, melts around 660 degrees Celsius. We use various furnaces: induction furnaces for precise control and flexibility, or cupola furnaces for continuous high-volume production of cast iron.
Why is getting the temperature exactly right so crucial, Ustad?
A few degrees here or there. Student, those few degrees can mean the difference between a perfect casting and a pile of scrap. If the metal is too cold, it won't fill the mold completely, leading to a misrun or cold shut defect. Too hot, and you risk excessive oxidation, gas porosity from absorbing atmospheric gases, or even damaging the mold itself. The pouring temperature, slightly above the melting point, must give the metal enough fluidity to fill every intricate detail before it begins to solidify. You mentioned oxidation. Are there other chemical reactions happening during melting? Absolutely. Oxidation is a big one, metal reacting with oxygen, forming oxides that float to the surface as slag. We often add fluxes to react with impurities, making them more fluid and easier to remove as slag. This cleans the melt. Crucially, we also add specific alloying elements like carbon, silicon, manganese, nickel, or chromium to achieve desired properties in our final casting. These additions are precise chemical reactions at high temperatures.
And after the metal is perfectly melted and cleaned, it goes into the mold?
Yes, the next stage is molding. The mold creates the cavity that defines the shape of our casting. Most commonly, we use sand molds, a mixture of silica sand, clay like bentonite, and water. It needs to be strong enough to withstand the molten metal's pressure and heat, yet permeable enough for gases to escape during pouring, preventing gas porosity. Cores, often made of sand too, create internal features. So once the mold is ready, we pour the molten metal very carefully, student, very carefully. This is the pouring stage. We transfer the molten metal from the furnace into a refractory-lined vessel called a ladle, which is then used to pour into the sprue. The pouring speed and stream must be steady. Too fast, you risk turbulence and air entrapment. Too slow, you might get a cold shut. And safety here is paramount. Molten metal is extremely dangerous. Full personal protective equipment is non-negotiable. What happens inside the mold after pouring? That's the solidification stage. The metal starts to cool and change from liquid to solid. This is critical. As metal solidifies, it shrinks. To compensate, we design risers, reservoirs of molten metal, to feed the shrinking casting and prevent internal voids, known as shrinkage defects. Proper cooling rates also ensure the correct microstructure, which dictates the mechanical properties of the final product. And then, after it's completely solid, we move to shakeout and finishing. In shakeout, we break open the mold to retrieve the casting. Then comes fettling, removing excess metal like the risers and runners, grinding off rough edges, and sometimes heat treating to achieve specific mechanical properties or relieve internal stresses. Finally, a thorough inspection for any defects like cracks, porosity, or surface imperfections. Ustad, what's one crucial real-world tip you'd give someone starting in a foundry? Listen carefully. Never compromise on safety and always respect the material. Molten metal demands respect. Understand your materials, what temperature they need, how they react chemically. A good foundry man has a sharp eye for detail, a keen understanding of physics and chemistry, and an unwavering commitment to safety and quality. It's a challenging but incredibly rewarding field, transforming raw material into complex functional components that literally build our world. Inshallah, you will master it.